Hello everyone, welcome to the lesson. This lesson I would like us to solve this question on linear inequalities. So the question is, determine the inequalities that satisfy the unshaded region. So here are the inequalities, are the lines bounding that required region. So you have line 1 is here, that is the x-axis, line 2 is here, then line 3 is here. So this is the unshaded region or the required region. So how do we get the inequalities that satisfy that region? We do take each line at a time. So I will begin by taking line 1, and I will get the equation of that line 1. Now when you look at line 1 is, this one is the x-axis. And what is the equation of the x-axis? The equation of the x-axis is y is equals to 0. Now we're supposed to write that one in form of inequality. Now look at this x-axis and look at the side that is unshaded. The unshaded region is the unwanted region. So we require to, so when you look at this, the side that is below that line, and that the area that is below that line is the one that is not required. So that is the one that is less than or equal to. Look at this line. This line is continuous. The side that is above the x-axis is the side that is greater than. So y is greater than 0. That is the side that is above that line, and that is what we require. The side below is less than. So since this region lies above that line, the x-axis, therefore the equation will be y is greater than or equal to 0. Since it is on the upper side of that line is greater than. You can see the values continue to increase, then the values below that line reduce. So we require side above, and that is y is greater than or equal to 0 since the line is continuous. Let's go to line 2. Line 2, look at line 2. Line 2 is a vertical line. This is a vertical line passing through x is equals to 1. So the equation of that line will be x is equals to 1. That is the equation of that line. It is a vertical line passing through x is equals to 1. So which inequality are we going to put here? Look at the side that is shaded. The left-hand side of that line is less than. The side that is to the right, and that is where we have the required region. The required region is to the right of that line. That is the side that is required. It is greater than. The side to the right, that line is greater than. The one to the left is less than. And since this line is continuous, it will therefore be x is greater than or equal to 1. So that is how we're supposed to write it, because the required region is to the right of that line, which is greater than or equal to 1, since the line is continuous. When we put that sign equal, greater than or equal to, even the points that lie on that line are part of the solution. This also satisfy the inequalities. Now we go to the last one. The last line is this line that is here. This is line 3. So line 3, I'm going to go down here. So line 3, we need to get the equation of line 3. Now to get the equation, we need 2 points. The first point is here. This is the first point that is here. So this point is 0, 3, and then the other point is here. This point is 3, 0. So identify the 2 points, any 2 points on that line, then get the equation. How do you get the equation of a line? We begin by getting the gradient. Gradient is a change in y. 0 subtract 3 over the change in x. 3 subtract 0. So this will give negative 3 over 3, and so the gradient is -1. Now after getting the gradient, we just need to pick one point, either 0, 3 or 3, 0. So I'll pick 0, 3, and I introduce another general point on that line to enable me to get the equation of that line, another general point, which is xy. So get the gradient with the 0, 3 and xy. You already know the gradient is -1. So let us change in y minus 3 over the change in x, which is x subtract 0, is equals to -1. That is the gradient. So this will give y subtract 3 divided by x is equals to -1. When you cross multiply these, you shall get this one as y subtract 3 is equals to x multiplied by -1 will give -x. Then from there you can take -3 to the other side, the right side, then -x to the left hand side. So you get y plus x is equals to 3. Y plus x is equals to 3. So this is the equation, that line. Now you need to know which inequality sign you're going to insert here. Now you just need to pick a point that is in the required region, and I can pick a point like 2, 0.5. 2 and 0.5, let's say it will be there. 2 and 0.5. 2 and 0.5. Let me pick that point that is on the required region. So 2 and 0.5. So let me pick that 2 and 0.5. Then you can test these. So x is 2, then y is there. So using that, I can substitute them. Y is 0.5. So 0.5 plus x is 2, then 3. Now you want to know which sign you're going to put here. So you have 0.5 plus 2 will give 2.5. So 2.5 and 3. So you notice that 2.5 is less than. So that is how you know how to which sign you're going to put here. So 2.5 is less than, and since the line is continuous, meaning all the points that lie on that line also satisfy the inequality, since the line is continuous, it will be 2.5 is less than or equal to 3. See now, after picking that point point that lies on the required region, and then you substitute x is equals to 2 and y is equals to, this is x is equals to 2 and y is equals to 0.5. So the sign, the inequality sign that you're supposed to put there is less than or equal to. Therefore, the inequality will be like this now. From here, the inequality will therefore be y plus x should be, this is the sign, less than or equal to 3. So that is the inequality. So those are the 3 inequalities that satisfy the unshaded region. So the first one is here, the second one is there, and then the last one is here. So that is how you're supposed to solve that question.